All right, so now you've seen the notation for a periodic function. F of x equals f of x plus p. If it's a periodic function, that means that we're just going to have the same y values multiple times at different x values. Let's talk about some specific vocabulary that goes with these periodic functions. If you notice, I wrote this a f of b times x minus c. You've seen this before, this from last semester. These are our transformations. And when we were doing like with x squared or x cubed, we would say a was a vertical stretch or shrink. And we didn't really have a b, but we would say that that was a reflection, or we'll find out here in a second that it's a horizontal stretch or shrink. And then my c was just a translation, was a horizontal translation left to right. Sorry about that. But I'm not going to use those terms when we're talking about a periodic function. They have special terms. So this A right here, we're going to call this my amplitude. Now, the amplitude is actually the absolute value of A. So if it was a -5, that negative is still a reflection, but the 5 part is the amplitude. This B, we don't really have a name for it. I believe Dr. Perry once told me it was angular frequency, but we're really not going to use that. We're going to use this to find our period. So we're going to use define period. And what a period just simply means how long does it take for the wave to, how long does it take before we get back to the original starting spot? And I'll draw out a diagram so you can see what a period is. This C right here is called our phase shift. Now that's just a big fancy term for horizontal translation, but if you tell me it's a horizontal translation, I'm not going to give you full credit for it because it is technically a phase shift because we're talking about periodic functions at this point. So let's kind of see how this looks on a diagram. So let's use our good old friend sine. Here's the wave of sine. And this is going to stop at 2 pi. We're going to just stop it, started at 0 and ended at 2 pi. My amplitude is from the highest point to the x-axis. This is my amplitude. So the amplitude is here and here. This is my amplitude. My period is how long does it take? So I'm starting right here at 0 and it's increasing in the middle of the wave. So I'm going to follow it all the way around and see, okay, well, here's an x-intercept, but it's decreasing. Here's the x-intercept and it's increasing. So this wave took exactly 2 pi radians to repeat. So the period is how long does it take to repeat itself exactly. Now we can't say here because you notice here it's increasing, but here the graph is decreasing. So even though it's an x-intercept, it's not increasing. Here it would be an x-intercept, and if we keep going on, it's increasing. So the period is exactly how long it takes to repeat. The phase shift is, say I wanted to move this graph this direction, and I put another graph on here, and let's say we started here, and we do that. It's how far it moved here horizontally, left or right. So that's just the phase shift. All right, so let's just kind of look and see what type of formulas we have to find the amplitude of a wave or amplitude of a periodic function. What is the period of a periodic function? And if there's a phase shift, what would that phase shift mean? Right now, we're not going to do too much with the phase shift. We'll do more of that when we get to the transformations of these graphs. But we definitely need to know how to work with A and B right now. All right. So we still have our form A f of b times x minus c. A is our amplitude. Well, to find our amplitude, all we're going to do is the absolute value of A. That's it. Nothing fancy. Just take the absolute value of A. To find my period, and the notation for period is like this giant upside down T. So that's for my period. We're going to do 2 pi divided by the absolute value of B. And that's it. And then my phase shift, it's just C. It's just whatever it is. I mean, If it's plus 8, then you're moving to the left 8 units. So it still works exactly like a horizontal translation, but we're going to call it a phase shift using the correct vocabulary. All right, so what does this actually look like? So say I have an equation of -9 sine of 3, why am I just 3 pi over 4 theta, something like this. And I ask you, here's my f of x. And I ask you, what is the amplitude of this wave? Well, the amplitude's really simple. My amplitude is the absolute value of a. My a is -9, so I'm going to take the absolute value of -9, and it's going to be 9 units. Whatever those units are, whether it's inches, feet, whatever, it's based on the graph itself or the word problem itself. So that would be my amplitude. Now, how about my period? To find my period, I'm simply going to do 2 pi divided by the absolute value of my b. Well, my b is this 3 pi over 4. This theta is this x. Because there is no c, I don't need the parentheses. So 3 pi over 4. Well, this comes down to 2 pi times 4 over 3 pi. My pi's cancel. And I've got 8 over 3. So my period is 8 over 3, 8/3. 8/3 units, whatever it is, based upon the problem itself. So really, it's just the mechanics. It's pretty straightforward math and algebra. You just have to know the vocabulary. If I'm asking for the amplitude and the period, I'm not really going to ask for the phase shift. If I do ask a question on a phase shift for a grade, I'm going to basically say the phase shift would be like this on blah, blah, blah. It's a vocabulary question as of right now. We're not doing anything with it. With the amplitude and period, you need to know how to find the amplitude and the period from an equation. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.